Hello friends, welcome to VK Lectures. In this lecture we are discussing the question number 15th and 16 from 2021 physics question paper. For a simple harmonic oscillator, we know that the phase space for a simple harmonic oscillator or linear harmonic oscillator, we'll write LHO, is ellipse. But looking into the option, we do not have ellipse in the option. It's all circle, hyperbola, parabola and cycloid. And ellipse has a formula. Ellipse with the formula p square divided by root of 2me whole square plus x square divided by root of 2e by k equal to 1. And we know that for ellipse, the formula for ellipse is x let us write y square by a square plus let it be x square by a square plus y square by b square equal to 1, where a is the semi major axis and b is the semi minor axis. Okay, now when a equal to b, it will become a circle. Okay, now according to the, while comparing these two equations, we know that x is p and y is x. Now the root of 2me is equal to, let it be a, and root of 2e by k is equal to b. Now for this particular question with the mass is equal to 0.5 kg and omega equal to 2 radians per second. Now what is the equation here? Let us write now let us continue with this semi major axis. A is equal to root of 2me. So m value is given as 0.5 kg, so let us write 0.5. so that is equal to 2 into 0.5 into e, that's equal to root of e. Half into 2 into 0.5 is 1. Now b is equal to root of 2e by k. Now even that we can write it as 2e by k is m omega square, where k is equal to m omega squared. So m is 0.5 into omega square is 2 radians per second, that is 2 square. That gives us 2e by 0.5 into 4. 2 square is 4. So the denominator is also 0.5 into 4 is 2. So 2 and 2 gets cancelled. This becomes root e. Now look at this 1 and 2. So a and b are same, that is root e. Now when a and b are equal, let us put in this equation x square by a square plus y square by b square equal to 1. If a equal to b, we get x square by a square equal to plus y square by a square equal to 1, and from that we can get x square plus y square equal to a square. This is an equation for a circle, so the option is option A. Now the same question, let us also look into this question in a different way, that the equation is p square by root of 2me whole squared plus x squared divided by root of 2e by k whole squared equal to 1. Now when the phase space of a linear harmonic oscillator become circle. So this is an equation for ellipse. Now let us see when this phase space diagram or the equation becomes that of a circle. Now if it has to be circle, then a equal to b, or that means the denominator root of 2me should be equal to root of 2e by k, which means 2me equal to 2e by k. 2 gets cancelled here, 2 and e gets cancelled over here, so which means m is equal to 1 by k, that's equal to 1 by m omega square, k equal to m omega square, which means if m square equal to 1 by omega square or m is equal to 1 by omega, then we can say that when m equal to 1 by omega, we can say that the phase space diagram for linear harmonic oscillator become circle. Now look at this equation, or look at this question. Here m is equal to 0.5 and omega, which is radians, is equal to 2. So what is 1 by omega? 1 by omega is 1 by 2, that is equal to 0.5, which is value of the mass. So this is an equation for circle. That means it makes the ellipse a circle with a equal to b. So question number 16. The question is 16 is about the Coriolis's force. There are 4 statements given. We have to select which of them is true. Now it's an invisible force. This is a definition for that, which appears to deflect the wind. Okay, so this is the first point. It appears to deflect the wind, and it applies to, that means this Coriolis's force applies to movement on a rotating object. For example, the airplane moving on the surface of the earth. Okay, now it's determined by the mass of the object which is moving, and the rate of rotation of the object. Now Coriolis's force is perpendicular to the object's axis. So if for example this is the aeroplane and this is the axis of the airplane, and this applies to the perpendicular direction, and this is the formula for Coriolis's force, Fc, which is given by minus 2m times omega cross v. This is omega vector and this is v. Omega is angular velocity while v is the tangential velocity. Now the strength of the field or the strength of the force depends on these parameters, which is mass, the angular velocity and the tangential velocity. and you have to remember that it is stronger at the higher latitudes and it has no effect on the equator because of this angular velocity. Angular velocity is the least in the equator region, and as it goes to the higher latitudes the angular velocity will increase. uh, uh, okay, so here is the origin of the Coriolis force. It arises due to the rotation of the earth. This is an important statement regarding the Coriolis force. That means the Coriolis force is due to the rotation of earth. Now as the earth spins on its axis, on the, let us consider this as axis. So as the earth spins from west to east, so this is west, this is east. Okay, so from west to east, it goes from west to east, then look at this, points on the equator move faster than the points closer to the poles. That means these points move faster because it is at the equator than these points. For example, if there are 3 points here on this circle, these points will move very slowly compared to these points. Similarly, the particle on these points move faster than the particles at these places. Okay, so this is the reason why there is an existence of Coriolis force, and this difference in linear velocity means along this direction, linear velocity results in the Coriolis effect. Okay, now what happens to the wind direction? What happens to the wind direction in the northern hemisphere? That means here, when wind is coming downwards, okay, it appears to deflect in this direction from higher altitude to the lower altitude. If the wind is moving in this direction, it appears to move towards this direction. Okay, wind moves in this way. Similarly, when wind moves from this region, that means from equator region to the higher altitude, it appears to move towards its right. Okay, here also it moves towards the right. Okay, in the northern hemisphere it moves towards the right, and in the southern hemisphere, if the wind is moving towards this direction, it appears to move here, and similarly towards the left. Both are moving towards the left of the wind. Okay, so this is left. So in the northern hemisphere, the wind moves towards the right, appears to move towards the right due to the Coriolis force, and in the southern hemisphere it moves towards the left. Okay, left of the wind direction. Okay, so it is in northern hemisphere, the Coriolis force deflect moving object to the right of their intended path. For example, here we have talked about the wind. Now suppose if an airplane, this is the northern hemisphere and this is the southern hemisphere, if an aeroplane is moving in this direction, okay, from higher altitude to the equator region, it moves towards its right. What is its right? Its right is towards this direction. So the the pilot has to adjust or the studies the motion of the aeroplane has to be in such a way that it adjusts the direction. Okay, and similarly in southern hemisphere it deflect towards the left, this is towards the right. Now it is also the reason why ocean currents and wind patterns often curve rather than moving in a straight line. Yes, there's a the ocean currents that you see in the waves. When you go to seaside, you see the waves curving around rather than coming straight to a direction. Here's a few more uh, points regarding the Coriolis force. A Coriolis force do not result from physical interaction. There is no physical interaction, but it is an apparent force. It's an apparent force that arises from the differences in linear velocity at velocities at different latitudes. So if it only affects the object moving along Earth's surface, so it only affects the object moving along the Earth's surface or the atmosphere and the oceans. Impact on weather, how it affects the weather, it is due to development of wind patterns. Wind patterns are being developed because of this Coriolis force. Moreover, it is ocean currents. Then it also contributes to formation of trade winds, western lines, and the polar easter lines. Okay, these are wind patterns. Now cyclones and anticyclones. The Coriolis force also influences the rotation and rotation direction of the cyclones. Low pressure systems, the cyclones caused due to low pressure systems, and the anticyclones which are caused by high pressure systems. In northern hemisphere, the cyclones rotate in a counter-clockwise direction. So in the northern hemisphere, this also we can do that. This is northern hemisphere counter-clockwise because it is moving. It's right. Okay. Now in the southern hemisphere, it's moving towards its. Assume this in this way. Okay. Towards it's in the clockwise direction. So in southern hemisphere the rotation is reversed, that is the clockwise direction. The flight path, that means the aeroplane path and navigation. The pilots and navigators must account for the Coriolis force when planning the routes, especially for long distance flights. Failures to do so, it can result in missed destinations. So if this Coriolis force is not taken into account, then if you want to go to this position from this, sometimes you will end up moving away, or sometimes you end up moving closer. This arises, it will depend on which direction or in which hemisphere you are flying. Okay. So coming back to the question 16, the four statements. So Coriolis force is a pseudo force. So we have already discussed about this. It is an invisible force. So the option 1, that means the first statement is correct. Now Coriolis force exists in all inertial frames, not in all inertial frames, only rotational, not all but rotational. Then rotational, and it must be with respect to an inertial frame. Now Coriolis force exists in a frame rotating relative to an inertial frame. Yeah, this is a far better answer. So I think option Yeah, option 193. Coriolis force exists in all non-inertial. No, it's not in non-inertial frame. uh, no, this is Coriolis force exists in uh, all inertial frame. No, not inertial frames. It has to be rotational and it has to be with respect to an inertial frame. Okay, and it's also an pseudo force. So option 193.